Hello. Quite a stretch around the world.
Bermuda. Wow, this is fun. All around.
Paulo, where are you tuning in from?
I'm tuning in from Stockholm in Sweden.
Sometimes you tune in through Brazil, right?
Yes, so I'm Brazilian, but now I'm in Sweden for the time being, enjoying the cold. It's really creeping up here already.
A little out of place, or maybe in the right place because maybe you love the cold.
No, I love to be here, but yeah, need to check in the warmth once in a while to get my tan and my sanity back.
Yeah, my mom in Puerto Rico really loves cold weather. That's why she moved to Michigan, but she needs her dose of sun. Sam is saying, spring and fall, please. So we have Hans from Denmark, Craig from Philadelphia, USA. Welcome, welcome. Sherman, nice to see you. It must be late for you. It's in Singapore right now. Welcome. Yeah, we're very glad to have this webinar as well. This is kind of the first time we're doing an official webinar using Corkbot. So we're really excited to have Paulo here, who's kind of the brains of the operation.
It's a shared operation.
That's true. Shared brain operation. Okay, we'll get started in about 1 minute. We're just waiting for all our attendees to appear. Cool, cool. Okay. Welcome, Anita from Poland. Pleasure to see you. All right, well, let's get started, shall we, Paulo?
Yes, Quirkbot time.
Quirkbot time. So thank you everyone for joining us for this session's Getting Started with Coding Robotics with Quirkbot Planar. So here today, my name is Lindsay, and I am kind of your co-host of this Planar. I am on the education team, as you know. Usually you've probably seen my face many times in these Planars. So I'd like to maybe draw our attention more to our special guest, Paulo. Paulo, can you tell us more about what you're doing and who you are?
Yes. Hey guys. So I'm Paulo, and I'm one of the people that's been involved with Strawbees since the beginning, and I got involved with the Quirkbot. So I was part of the team that developed this hardware, and I'm a programmer, and I'm a person that really sees programming as something empowering because it happened to me personally, right? So I've learned to code on my own, and it really took me places. It really gave me the career that I have, and it really opened up my whole world. So I came into this with this very personal wish to, well, get kids to experience what I experience, and then we set to design this board that would allow kids to experience programming in a more creative and fun way. And my angle is programming, right? So since the beginning, I've designed the language that we used to program the Quirkbot, and I've pretty much created the whole software behind it. So I'm definitely a person that knows Quirkbot inside and out, every single detail of it, every single software, from what runs inside the board to what runs on the servers. So it's really a pleasure to me to be here and talk with you a little bit more about code and how and the way we do things. Yeah, so I'm not so experienced as Lindsay in hosting webinars, so please bear with me. But I'm happy to be here, so I guess it will flow.
Thank you, Paulo, for letting us know. I mean, you have a very extensive past, and also you're just a pleasure to work with. And you actually do these, informative sessions with Corkbot quite often. And I think it was beneficial for the world to see how Paulo has been facilitating this experience over the years. And also, we are announcing a new feature, which I will let Paulo talk more about later through this planar session. And then I also want to give a quick shout out to Vivian. So Vivian, can you just wave your hand? Thank you, Vivian. Hello. So Vivian here is going to be helping us with answering some questions. So please feel free to answer questions in the chat. Let us know if you have any concerns, or even if the video could maybe move it a little closer to the camera. So Vivian will be also facilitating and answering your questions in chat, but also asking Paulo or myself if we're in the middle of presenting, if you have a question. So we will actually try to answer some of your questions as we go along. But of course, we also will be saving a lot of extra time, the last 5 minutes, definitely for answering more questions extensively. So if you have any technical questions about coding, more about the resources, let us know in the chat, and we'll try to answer as fast as we possibly could. Thank you. Thank you. All right. So now I want to do kind of a quick info session about what is the Corkbot. So now I'm going to just change my camera so you can see. And I'm just going to spotlight. So for some of you might be familiar with the Corkbot. And I apologize if it's a little blurry. Sometimes the camera changes, but it'll just take a moment for it to reset. So this is the Corkbot, and basically it's basically a microcontroller that you can upload code. So you have it basically looks like a Strawbees connector. So some of you that have been building with Strawbees may have noticed that we have a 5-legged connector, and this the Corkbot is basically like a connector. So what's really unique about this board is that it also can be attached easily to the straws and to the Strawbees connectors. So you can really think about hardware and code as literally a connector itself. So I want to show you kind of the features that it has with the hardware components. So this board I've already pre-programmed so you can just see how it works. So it comes with these LEDs for eyes that you can program, but I have already preset it so you can just see how they work. But it also comes with small LEDs. These are dual colored LEDs that you can pinch the legs like so. And then what I can do is I can squeeze them onto the arms and the legs of the Corkbot. And then what's really nice is I can slide a straw on the LED itself, like so. And it actually holds the components in place. So we have these LED components, as well as something called a light sensor. So it's basically a component that you can also attach. So by squeezing the legs of the light sensor, you can squeeze onto the horn. So we have the Quirkbot that is featured with the horn, the arms, and the legs, because how Paulo likes to explain the Quirkbot is kind of like a creature. And where you are on this, on the Quirkbot. So when you want to put LEDs in a certain place, you can say the left arm or the left leg, or I want to attach the light sensor on the horn. So you know roughly where you are on the Quirkbot. So I can actually just turn on so you can see. But what's really cool is that you can actually attach the components like the LEDs inside the straws, and you have this kind of like light, I guess, light pipe is kind of an interesting way to explain it. And then also what's really interesting is that we have these servo motors that you can attach with these motor mounts. So on the motor mounts here, which I will just slide in carefully, like so, I can set it up where I can make my Quirkbot move and control a servo motor. So in order to set it up, I would have to attach a piece called a backpack. So this backpack is specifically for servo motors, and I would just attach it, connecting the pins to the headers like so. Sometimes it's a little hard to follow. There we go. So then just push it in. And then I can attach up to 2 servo motors on the backpack. So then also on the backpack, you can see that there is a black line. So that black line that is silk screened on the backpack tells me that where I want to connect the servo motor here with the black line, the black wire of the cable to this black line. So now I know roughly how to attach it on like so. So now my servo motor is connected. So now if I want to, be able to connect my pieces together, I have these motor mounts that I can slide on like so. And then what I can do here is just slide them on. So now they are snug. And then I can easily attach a straw. So I can snap it onto a straw like so. There's also these little plugs on the end where I can attach to the straw this way. And maybe to prevent it from popping off, I can slide a Strawbee connector to secure it in place. And then also what's important is maybe I want to make the straws move to control on this servo motor. So this servo motor that I'm showing that comes with the Corkbot, the Coding Robotics with Corkbot kit, is a 180-degree servo motor. But it also can work with continuous, but that one is sold separately in our spare parts. So we also have these special servo Strawbee arms that you can attach on like this. So I can make it turn, and then I can attach straws along the arms of the Strawbee arm, but I can also build up just like this. So I can build, I can build up, left, right. So there's a lot of dimensions that I can use and build on the servo motor. But then I can also even attach the Quirkbot to my little wacky creation here. So I can actually put a 2 arm, and I can also switch it out for a 1 arm. And then also what comes with this is maybe you want to create your own kind of arm. So this one is like specifically with 2. So if I attach it here, I have one with no arms on the servo arm. So what that means is that I can even put this 5-legged connector, and I can make my own Strawbee servo arm for my creation here. So I can just show you my simple little example. Yeah. And then also I noticed that Sam made a really interesting point that this is a dual colored LED, meaning that I can also flip the LED around and it'll change colors. And Paula, you were going to say something. Did you want to share something?
No, I was actually going to point out exactly this, that it is a dual LED. So it's 2 LEDs in one. And then through programming, we can actually switch the colors without the need to switch the LED like you did right now. So with programming, we can display it red, we can display it blue, and all the colors in between that.
Mm-hmm. Definitely. So that's kind of the brief introduction to the hardware and the electronics that come with the kit. So now I'm going to turn it over to Paulo, who's going to show you Strawbee's code and the new features and how to program.
Great. Thank you, Lindsay. Can you please do the screen sharing?
Yes. Just one moment.
So you guys know we're actually doing something very very remote and connected here. So because I don't have the sort of the camera gear to film the Quirkbot as Lindsay has, I'm actually going to program the Quirkbot through her computer. So I'll actually get remote control of her computer. And yeah, and with that, program it over there. It's just interesting feature that shows that we actually can do some remote programming. Yeah, these days that working remote becomes so important. But here we go. Let me request control over your screen, Lindsay.
All right, there you go.
And yes, I guess I am in charge now. And thank you for presenting the physical parts of the Quirkbot. Just before I jump in a little bit into the code, I just want to underline that thing that Lindsay said, that we like to think of the Quirkbot as a creature. And we find that this is actually a very useful metaphor. It's not only something that we just made up, but this metaphor, it really allows for a lower floor, like an easier way for referring to the parts, as Lindsay says. So instead of saying like pin 35, we can say the left arm. And that's a quicker way to grasp. We really saw this with younger kids. But also that this, by thinking of it as a creature, it does allow for this more expansive way to think about computation, because we can start making parallels with living organisms and how life itself has a lot of computational thinking embedded into it. So we can create programs from the perspective of almost like creating life. And this widens the wall. So this allows for other people that are not, maybe so into tech or like engineering, but more interested about life and animals and creatures. We give them a hook to think about programming from that perspective. But with that said, I will dive deeper now into code, which is how well you get to program the Quirkbot, right? So first things is about, well, how do we access this software? So there are two ways to go about it. One is to visit code.strawbees.com with one one thing to keep in mind is that you should use the Chrome browser in order to be able to access the Quirkbot, the hardware. This is because the Chrome browser has support for serial communication, which allows us to talk with the board. But in case, let's say you're not interested in using the Chrome browser, or for some other reason you don't want to use it, we also offer a downloadable version of code, which you can access on code.strawbees.com/download. And in here, you're going to find builds for Windows and Mac. And they have an extra advantage that they don't require internet to work at all, right? So when you are using in the browser here, you will need to be connected to the internet, both to save your programs, but also to actually program the board, because we need an extra server to prepare the code. But you don't need that if you are using the offline. So it may be the best solution depending on your case. And then quickly, you can obviously sign up and log in to the system, and that will allow you to save your programs. But in case you don't or can't, or don't wanna sign up, you can use the interface as a guest, and you will be able to program your board as well. Okay, so now let's talk a little bit what you see over here. So one thing that is very important about the way we think about programming is diversity. And diversity in programming languages and paradigms is very important. We really want to make sure kids get exposed to different programming paradigms, because there is no such thing as a language that is better than the others, but different languages are better for different kinds of problems. So we really wanted to have that built in. So we have 3 ways of programming the Quirkbot. I'm going to do a quick roundup on all of them. So we have the flow-based programming, which works with connecting these visual nodes over here. And this is a paradigm that is, it's actually very suited to think more in a general way about systems. Like, it gives you an overview. It tells you what you want to do, but you don't need to explain it in terms of step-by-step instructions. And in Flow, we have this concept of inputs, outputs, and brains. So you basically are connecting inputs with brains and connecting brains to outputs, and that's how you build your program. We also, I'm not going to save this. Oops, it's proceed. We also have block, and for those that are familiar with Scratch, you notice that this looks exactly like it, and it looks exactly like it because it is powered by Scratch blocks, which is an open source library offered by MIT, who developed Scratch. And so this will be the focus of the presentation today, because this is what we see the easiest entry into the programming world, given that so many people are used with this block-based paradigm and have been using Scratch. And also you can program it in raw C++. And what you see in here is basically an Arduino sketch for those coming from the Arduino world. The Quirkbot is 100% compatible with Arduino. So there is a way of programming it too outside of Strawbees CODE, and that is through the Arduino IDE. You just need to install the Quirkbot library, and then you have full access to the hardware. So this is important for us, right? Really having a high ceiling, like not putting an artificial limit in what you can do with the board. You can actually program all the way if you're interested. And one thing that you have over here as well is this button, upload factory program. So when Lindsay was showing that initial demonstration of the Quirkbot, it was running what we call the factory program. So this is a program that comes loaded with the Quirkbot when you get it. And it's interesting because it does a few things that you could use to engage students and create activities right away without the need of programming. And this button basically will allow you to reset the Quirkbot to that factory state. And it's something that we recommend, for example, to do before you're running a workshop or starting a lesson. You can just make sure all Quirkbots are in this factory state, because it's a very good way to start. So maybe Lindsay, do you want to plug in the Quirkbot and we just demonstrate here the factory code. So now Lindsay plugged it in, and something happened here, like in the bottom of the screen, on the bottom left here, it's showing ready. So one thing that I forgot to mention, the first time you're using Google Chrome, this corner here will say something. It will say missing helper, click here to install. And once you click on that, it will take you to the Chrome web store, where you can, with one click, just install a Chrome extension that will allow us to communicate with the Quirkbot. So that's the first step, really, because if you don't do that, you're not going to be able to detect the Quirkbot. But because we've done it already, everything is ready. So Lindsay plugged in the Quirkbot. We can see the Quirkbot is ready in here. And now if I wanted to erase what it's in it and just upload, reset it to the factory program, I can just press this button. And it's now uploading. And yeah, so now the program is running over there. And well, what the factory program does is to, Lindsay, if you can bring it a little closer to the screen. So it will blink the eyes, the two blue LEDs there. And on both arms and both legs, you can place this external dual LED. And on here on the example, we have only one, but you could put up to 4 of those. And it also showcases how you can control the motor. So by default, the program will do this. If you plug the motor in, it will move the motor side to side, which is a great starting point to a construction. You can just get something moving. But if there is the 2 slots, right? Number 1 and number 2 for the motor. If you would switch them, and maybe Lindsay, you can do that quickly. If you switch from number 1 to number 2, it will change the speed of the motor. So maybe it's hard to notice just here on the feed, but now the motor is moving quicker. So the motor on 2 moves twice as fast as the motor on 1. And then there's also a third feature that is showcased on the factory program, that is the circuit touch functionality. So the horn of the Quirkbot on the top there, if you touch it and you touch the front and the back metal pads, it will activate something. It will activate the circuit touch. That on this case, it will it basically switches the motor 1 and 2 in terms of speed. It will light up the green LEDs from the mouth of the Quirkbot. So Lindsay, if you just like release it and press it again. So notice there, close to that red LED, it will turn green once Lindsay touch it. Yeah, and also the arms that we have the dual LED, they also switch color. So they are blue now that Lindsay is touching them, but if she releases it, it will turn red. So the factory program showcases all the basic features of the Quirkbot, and it's just a great starting point. And as we like to say, programming doesn't need to happen on the screen, right? A lot of the times it should not start on the screen. It makes more sense to start building something and sort of looking how the movement is happening, adjusting the straw, adjusting the position, and program your structure by modifying it physically, and then have a reason to go into the programming world in order to modify that. So, well, with that said, now let's go into the programming world. So the focus today will be on the blocks. So I'm going to deep dive a little bit into this mode. And Lindsay, can you make me a favor and just zoom in on the screen? Just sort of press Command plus, I guess. Yeah, just so we can see a little easier. Thank you. I think that will do. And so if you see here, the different blocks we have available. We have a few categories: events, input, output, and then control operators, variables, and my blocks. So if you're familiar with Scratch, from control down, this is the same things. So here are basic flow control operators. Here we have basic math operators, a way to create your own variables, a way to create your own blocks. So this is a Scratch, right? Then we have the things that are particular to the Quirkbot, and this is the input. So we have blocks that represent the inputs. So we have one that basically is a Boolean, is a true or false, that lets you know if you are touching one of the arms or legs or the horn. We have that as a number format. So basically it will be 0 if you're not touching it, will be 1 if you're touching it. And we also have an input for the light sensor. So this is also a number that goes from 0 to 1, depending on how much light is being received in that sensor. Then we have the outputs. So these are blocks that make some effect into the real world. And in here we have the servo, which basically you can select what is the servo, and you can set a position from 0 to 1 that will correspond to either the initial position of the servo or the full movement, right? We also have the transition servo, which is a little bit more involved. If the set servo position is something instant, like you say, set position to 1, the servo is just going to move to 1 as fast as it can. The transition servo allows us to define a duration for that transition. So if I just read this here in natural language, it's saying transition servo 1 position to 1 over 2 seconds. So this would, if I make an example like this would first set the servo to position 0. Then it would take 2 seconds to set it to position 1. And what is interesting with this is that we can control the shape of this movement. So we have some easing functions in here, and I mean, no need to understand this in depth, but basically by controlling this, you can decide if the servo should start moving slowly and then speed up, or like start very quick and then slow down. So it allows you to create a lot of very natural motions with this. So it's definitely something worth exploring. Then we have 2 blocks for the continuous servo, in case you have a continuous servo. So it is a different hardware, right? It's not the same motor. The usual servo, the ones you're seeing on the screen, on the video, they can only move a fixed range. But if in case you can get a continuous servo, then you would use these blocks. And then you basically have a block that controls the speed. So again, is a value from 0 to 1. 0 is stop, 1 is spinning as quick as it can. And then you have another block that lets you decide which is the direction. So if you want to spin clockwise or counterclockwise. Then we have blocks to control the LEDs. So we have one to control the single, let's say single color LEDs. And these are the ones that are built into the board. So you have like the left eye, the right eye, the left mouth, the right mouth. Or in case you place a LED on the legs and arms or the horn, that is a single color LED, that could be off the shelf LED. And then if you're using the dual color LEDs, the ones that come with the kit, they have 2 blocks to controlling them. One works just like the one for the single color. It just sets the light between 0 and 1. But then you can also set the color. And again, that's a value between 0 and 1. And what do we mean by setting a color between 0 and 1? It represents the spectrum between the red and the blue color. So if the color is 0, it is red. If the color is 1, it is blue. If the color is 0.5, it's going to be like a purple in between blue and red, right? So that's how you control the colors with the blocks. And last but not least, we have some blocks to control the keyboard. So one thing that the Quirkbot can also do, once it's plugged to the computer, is to mimic a keyboard. Maybe some of you are familiar with the Makey Makey, which is a product we love. And that you can use it to press keys on the computer. So you can do the same kind of thing with the Quirkbot, but with the advantage of being able to program that, right? So you could sort of on demand ask the Quirkbot to press the space key, and then you could do another command and ask it to release the space key. We also have a feature for the tap, which is sort of basically pressing the key very quickly. And another one that allows us to specify for how long we want to hold that key down. So this could be very useful if, for example, you're using the Quirkbot to create some sort of interface for some game, or to create a music instrument. You could use this to sort of like press keys and basically play some melody for you. So these are the inputs and outputs that are specific for the Quirkbot. And now there are the events. So this is a new feature that I'm super happy that it landed, because some of you that maybe been using the Quirkbot before, you would have noticed that before there would always be this programming here. There was this block in here that it's the when program starts, which is sort of the starting point of your program, right? So everything you sort of put over here will happen as soon as your program starts. But you could only have one of those blocks, which was fine if you were doing simple programs. But the moment you wanted to do many things at the same time, it would become more complex. You would need to start thinking about the states and basically having a big loop and switching between things. So I'm very happy to announce that we now have event blocks that can be multiple entry points into your program. So this is going to be very useful, for example, if you're trying to move one motor in one way and move another motor in another way. You can simply think about one motor in one event and think about another motor in another event. Or if you're trying to make LED lights blink in different ways, you could pretty much create one of those blocks for each LED you want to control, and then control them individually. We also, with that, got a new block that is the when condition. So this one, it allows you to basically have an entry point to your program that will be triggered every time a conditional event happens. So I guess the best example of that is using that together with the circuit touch block. So basically now I have an entry point. I have a code that will run when the horn is touched. So if I wanted to like blink LED when I touch the horn, I could do so like this. Let's say I turn on the LED, I wait 1 second, and then I turn it off. So it becomes a very easy way to get an entry point based on on an event. But it doesn't need to be limited to this, because this block will accept any conditional. So you could even have, let's say, a conditional block in here, and I would create a variable, like let's say a counter variable, and I want to do something, and let's say I want to increase this variable every time I touch the horn. So I could do a program like this, that if I touch the horn, I want to increase my counter by 1. I have to put a small delay in here, just in case if I just hold the horn, this code would run repeatedly, and it's not the effect that we want. And then I could do something once that counter reaches number 5, for example. So you do some things and then something happens. So being able to have events really opens up the paradigm of programming, because you can think in event-based programming, and it can make your code look much more simple and much more expressive. All right, with that said, I'm gonna do a quick demo here of a real-world program. And with that, I'm gonna switch here quickly to our learning platform. So at learning.strawbees.com, you can find lots of resources, lesson plans, activities. And right now here we have the activity of the robot racer, which is like a very, an activity that is always a hit, because it's simple to set up and very fun to do, in which we create a robot that can basically walk forward. So I'm just going to play this video here just so you see an example of that. And it's interesting because you can physically adjust this robot, like by moving the motor around, or by changing the length of the straw. So it really connects to what I was talking earlier about the physical programming, where your variables in this case is the length of the straw that you can manipulate by changing the straw itself. So if you haven't tried the robot racer, I really recommend checking out this activity. This activity is actually part, or it's also included in a lesson plan that we have. That let me see if I can open from here. I can go straight from here.
And while Paulo is at lesson plan coming in, which I think we will address shortly. So we will address perhaps a little bit after Paulo finishes this demonstration.
Lindsay, I'm not sure if this was just for me, but you sounded like a robot, like the sound really chopped up. Vivian, was it for you as well, or did you listen?
Yes, I think Lindsay, basically there have been 7 questions popping up, and I believe Lindsay quickly wanted to go through a few of them. Lindsay, do you want to try again just to talk, or shall I take over?
I think I was saying let's wait till the end of the demonstration, because there's a lot of hands-on demonstration required.
Okay, cool. So just showing this quickly, this Robot Olympics lesson plan is an excellent way to work with this robot racer in the classroom. But the idea is in here is that you could actually transform this racer into many different kinds of sport players. or can, instead of being the fastest robot, it can be the robot that can pull the more weight. Or you could change the theme completely and do like a dancer robot, and don't engage in sort of a competition of those sorts, but engage in more like a show off of different dance moves. And I just wanted to show that because I can show how we could program a robot racer. So there is one thing that I didn't show yet that is also quite interesting. This is our coding cards. So we have a few coding cards for the blocks, and they are divided by basically the hardware that they are using, which is the input and which is the output. And they are an excellent way to get started with coding and just to get some ideas of the things that we can do. So we have like many, we have many coding cards in here. And in order to build the robot racer, I would start with the back and forth coding card, which is a very simple one, which is setting the motor to a position 0 to 1 repeatedly. And I can go in and open this in my editor. So now I can load this program in. So let's just see what happens. Let's just upload this program directly to the board. So it's uploading now. So as you can see, it dropped the robot over there, and that's part of the fun. So now we are moving the motor from the position 0 to the position 1 with a 1 second interval. And well, I'm not being able to control the screen right now. It seems there's some problem with Lindsay internet. Well, I'm just gonna talk on top of it for now. Okay, since we're back. And with this coding card, I could now start, fiddling with this code instead of starting it from scratch. So let's say, I think 1 second is too long in between the movements of the motor. I could come in here and simply reduce the delay. So let's say I'm gonna use 0.3 and then 0.3. Yeah, please bear with me. The delay is due to the internet connection. Okay, okay, seems that went through. So I'm gonna upload this program now. So if you notice on the video now, the motor is moving much quicker than before. And I could also reduce the range of the motor by changing the position. So instead of moving it from 0 to 1, I'm going to move it from 0.3 This is a little bit frustrating that this is having so much delay. So, okay, this is, I uploaded the program before I was ready. So now nothing's happened because I'm changing between position 0.3 and 0.3, so nothing changes. So now I make a new upload. Okay, so now I'm moving a little quick and in between 0.3 and 5. So now I have a great program for a racer, and I could sort of finish it by tweaking the hardware. So I could move the motor position, I could move the straw, so that, yeah, it would become a walker, for example. So that's yeah, just an example of how to use the coding card in order to make this simple yet very fun and engaging robot. So just so I can show one more thing quickly here, how could we, for example, advance this coding card? So there's this thing about coding cards, right? They will always be incomplete. They will always take you almost where you want to go, but then you need to think, right? And that's the point with them, to just sort of inspire you, put you in a direction, but then you can complete that yourself. So I'm going to transform this program, instead of a robot that is just moving all the time, infinitely and repeating, I want to make a robot that it's going to move only 10 times or 5 times. And this could be a different kind of game or different kind of competition, right? That is a robot that it only gets 5 chances to move. How far can it go? So in order to do that, I'm going to, instead of using the forever block over here, I'm going to use a repeat block. And oops, this is slightly strange, is because there's a delay when I'm controlling Lindsay's screen. And I'm going to move this code inside. And I'm going to change this to 5 times. And I'm going to delete this. So now I have a code that will, and I'm going to add one more thing, that is the horn. So now I have a code that, instead of just moving repeatedly forever, it's going to move 5 times when I touch the horn. So basically I can activate this robot, see it move, then activate it again. So let's upload this one. So now, yeah, if Lindsay touches the horn over there, it's gonna move 5 times and then stop. And if she would touch again, it would move 5 times and then stop. But okay, I mean, I'm looking at the clock and the time just flew over here. That usually happens when you are coding. You're not gonna see time passing. But Lindsay, maybe you can take over again and we can, well, start wrapping up this session.
Absolutely. Thank you, Paulo, for the great session. So now I'm just going to stop sharing my screen. And then you're going to see. Okay, here we go. So we got quite a few questions, but we decided to wait till the end to answer them, because a lot of them, I think, required some demonstration. So maybe, Paulo, you may have to share your screen to show, or I can also show as well. So our very first question is from Sam. Do you have any more tips for keeping the servo motor arm more secure and attached to the motor? So that is actually a great question, which actually I can present, because I think that could be more of a physical demonstration. So this is actually a very important element that I forgot to mention. So the Coding Robotics kit comes with a tiny screwdriver, the tiny but super mighty screwdriver, and an even tinier screw that is too small to show on screen. But it is something that you can screw into the servo motor, which perhaps I can actually switch back my camera so you can see it a little bit better what I'm talking about. So let's see here. So if I just shift my little robot friend over, so there is a tiny screw that you can insert inside a servo arm. So in the servo arm, there's like a small hole that I can take and detach currently because it is not screwed and secured to the servo motor. So all I need to do is to fit the screw inside like so. And then just give it a light twist, a few twists. So then now it'll prevent the Strawbee servo arm from popping off. So this is especially really helpful if you have a robot walker that maybe you don't want the arm to fall off constantly, and it can kind of handle a lot of the friction from the movement of the servo motor. So this is actually a nice feature that we include in the kit. But of course, you can always unscrew and detach, especially if you want to change the motion, or maybe you're not happy with the position of the movement. So this is something that you can also have with the hardware that you can change. So that's like our response to that question. And then the next question is from Christine. Can you download files that were saved online? So Paula, maybe you can take this one.
Yes, so absolutely you can. It's possible to export the files. Maybe I can show this quickly here through my screen. I hope you guys are seeing my screen. So let's say I create a new program, my test program, now using Flow. So this is a program that would make the eye turn on if you touch the horn, and I save it. So when you save in here, it's actually being saved to your browser, right? So I could just come back and the program is over here. But if I want to save this file as a file on my computer, I can then simply come here and I can click on Save to Computer. So it will save a little JSON file that you could import later on. So I could do it again. I can do it even directly from here. So I create a program, very simple one, that then I can directly save to computer. This one is Untitled because I haven't given a name. And then later on, let's say I come back here to the start page, I could load from computer. So now I can just drag the file that I have saved earlier, and now I have it. So yes, you could do management of programs just by downloading the individual files of it.
So you think that it could be easy to share code with students, as Christine was asking?
Yes, exactly. So that's a easy way to share the program directly with them. So if you have something that a learning management system that allows you to share files, you could share the file directly and then import it from there. Otherwise, you could simply share the link to this program with your students. So that's another way to do that. For any program, you can always go to share, and it's going to give you a link of the program, so you could distribute it in that way as well.
Okay, thank you. And for the text-based coding in C++, would it ever support Python?
Well, this is not on our current roadmap, and this has to do with what the Quirkbot supports. So no, Python is not coming. I'm not saying never, because there are other, I've been looking with sort of transpiling different languages. I have early tests with JavaScript that actually worked quite well, but I don't want to make a promise on that right now.
Okay. And another question is from Sam. If the Corkbot works with Scratch, using the Scratch blocks, he's wondering if it ever could be added as an extension on Scratch's website.
Well, potentially it could. It's a more involved work. It would require doing a special firmware for the Quirkbot that would work with Scratch. We've been looking into this kind of options, but what I would say is that you can still use the world of Scratch with the Quirkbot, but using the Quirkbot as a controller, because as you remember, we can program the Quirkbot to be a keyboard, right? So if I would make a key press, for example, when I touch the Quirkbot, I press a key. I could now essentially use the Quirkbot to control a Scratch program that I've done. So you could use it like that to combine both worlds. So by all means, you should do that. It's actually quite fun to make your own game and then make the controller for it with the Quirkbot.
Okay. And we have a question about the sign in, sign out, cubic in and out, quad in and out. Where can we learn more about that? Is it currently in the pipeline?
Yeah, so I mean, there's lots of documentation features in the pipeline that will explain more about everything. But if you're interested specifically on those curves, the sign in and out, I would just recommend you going. I'm gonna post an address because these are easy equations and there are plenty of resources on it. Actually, if I have my screen, I can just show it here. So
yeah,
easing equations. So if you just Google this, easing equations, you're gonna find many of them. Let's see if I'm just taking the first one. That's a great one actually. So here we can indicate how the different easings would affect the motion. And we have even sort of, no, this is not a so good example. But yeah, so if you would pick, for example, is in cubic, and look at this little pin here on the right, it shows sort of how the movement happens. So it starts slow and then gets quick. And in quart is sort of the same, but with a more slower sort of ramp up. And then you have the ease in and out. So for example, this one, it starts slow, gets quick, then slows back again. So those equations that you see on Quirkbot are the same ones that you would find over here. Yeah, so the best way is to actually experiment with the motor so you can see how it changes the motion. But here is the sort of explanation of what they are.
Okay. Thank you, Paulo. I think this question I could answer next. So is it safe to use the Corkbot with other LEDs other than the ones with the Strawbees supplies? And the answer to that first part of the question is yes. You can use regular LEDs, like ones that maybe are just white or a different color. You can definitely use other LEDs. The other half of this question, can you attach multiple LEDs to one arm, leg, or horn? I've actually never personally tried that, but I think ideally no. Paulo, would you like to chime in?
I mean, well, actually, yes, you could get two LEDs into the same arm, provided they are sort of with the same polarity. The electricity would flow through both of them and would make something happen. But it goes a bit into the undefined land, right? It depends on what is the internal resistance of the LED, if that would work or not. If, for example, however, you have LEDs that are flipped, then obviously only one of them is going to get the current. By all means, it's not dangerous for the Quirkbot to do that. You could experiment, but I must say I never actually tried that. So if you do, let us know. But one thing is you can't program multiple things on the same arms and legs, right? So if you would have a light sensor and the LED on the same one, then this is not going to work because you're going to have a conflict in there of what the program is trying to do. So yeah, so I would not recommend it, but who am I to say what you can or not experiment with?
Well, that's how the Quirkbot was born, wasn't it? It was
Yeah.
actually kind of found at a kids hackathon in a way. And it
Yeah,
was
yeah.
kind of developed, co-created with children.
Exactly. Yeah, it came out of the Kids Hack Day event that we started a couple of years ago, and as a way to engage the kids into programming.
And now the next question is, can it support RGB LEDs?
Yes, it can, but then we need to define what kind of RGB LEDs are we talking about, because there are different types out there. If you're talking of RGB LEDs, which is essentially 3 LEDs into one, you would basically need to connect those 3 legs of the LEDs into the backpack of the Quirkbot. So we didn't go into this, but the back of the Quirkbot, you have extra pins that are addressable. And in that way, you could control the LED by individually addressing one of those 3 pins. If you're talking about things like NeoPixels, which is a slightly different technology, you could, but you start needing more support components. For example, the NeoPixel, it requires a 5 volts voltage to run, and the Quirkbot provides only 3.2. So you would need something to up the voltage and then plug into the back. So I would not recommend that something to start with, because it will, it will lose the beauty of like snapping quickly the electronics, and you start to need to sort of breadboarding. But technically it's possible.
Great. So then another question about that is, Cork, can you combine, where can you find more information about combining Corkbot with Arduino? Oh, we have quite a few questions coming in here.
Yeah. Well, I would say, unfortunately, there isn't a very clear guide on that right now. But I think the best way to find that is on our GitHub page. So actually the Quirkbot GitHub page. So if you go to github.com/Quirkbot, there are two pieces of software in there that are relevant. One is the Quirkbot Arduino library. And if you go to the releases, we can share these links afterwards with you. Here I have basically how you install the Quirkbot Arduino library. But in order for it to work, you actually need to install something else as well, which is the Quirkbot Arduino hardware. So that Arduino recognizes, so that Arduino recognizes Quirkbot as a specific board. But if you install both of these things, then you can work inside Arduino. But there's going to be a lot of tutorials on that right now. But you know how to reach me at paulo@strawbees.com. Please talk to me. I'll be happy to continue this conversation.
Absolutely. And I'll just answer a few questions quickly, and Paulo, feel free to correct me. A question about the coding cards. Will there be flow and text-based programs? The question is, that is in our pipeline. We are working on it. We have a lot of creative content coming from documentation of the code blocks, and also more coding cards, including enhancing the coding cards to reflect in the block ones that already exist, the event blocks. So quite a bit of content we are creating for this. And the next question is, including the 360-degree rotation servo. So yeah, we have the angular servo, which is like the 180-degree, which Paulo and I featured. And currently the 360-degree rotation servo is sold separately, and that is still the case. So the reason for that is that we wanted to make that kind of optional, so that way it doesn't get too expensive, and it could be something that you can buy as many as you need. So we wanted to only provide the 180 to lower the cost. But you can look in the Strawbees store under spare parts, and you can find and purchase that rotation servo separately. And then another question is about the offline editor. Yes, so the question is, will the code editor have an offline version? So yes, we actually currently have an offline version. So on code.strawbees.com/download, there is an offline app that you can download to your computer, and that requires no internet access. So this is a way for learners that maybe have lack of access to internet, or we created this app for this purpose. So again, that is at code.strawbees.com/download to find the offline app. And then I believe we have answered all our questions. Our last question I see, actually, do you ship to Bermuda? So if you can send us an email at sales@strawbees.com, because I think none of us can actually answer this question, but we have to check. So Andrea, make sure to send us an email at sales@strawbees.com. And then I believe we are actually officially done with all the questions. All right. Great, great. Thank you everyone for tuning in to our Coding and Robotics with Quirkbot Planar. And thank you, Paulo, for joining us today. It was a pleasure having your technical knowledge, but also wealth of extensive experience in programming, and also sharing your experiences of how you teach programming, because I think I can definitely speak on behalf of everyone at Strawbees that it is always a pleasure to hear you describe your process when it comes to coding.
Well, thanks for having me. Thanks for listening to me ramble around programming. Sorry if I maybe went a little bit over time, but I am truly passionate about this, and I can just talk forever about programming. So thanks for bearing with me.
Well, I think the good news is that Sam actually made a joke that I can keep asking more questions if you would like. And I think that many of us here really benefit from being able to ask our CTO a lot of these questions. So I think maybe we should consider having you in a future planar again.
Yeah.
Ask the CTO.
It would be my pleasure.
Yes, and I think you can share a lot of interesting stories more about Kids Hack Day as well.
Yes, yeah, there's lots of good stories over there of the journey until we got to this point.
All right, so now thank you. So if you want to tune in for future webinars, join us at strawbees.com/webinars or strawbees.com/professional development. We'll be updating with a new webinar, musical instruments, and also another webinar, which is new for Vivian to hear, is Hour of Code in December. So wow, I think nice. You will see Paulo and Vivian back very shortly. All right, thank you, everyone. See you next time.